Let's look at finding the inverse of a function. For example, let f of x equal 1 minus 4x. Let's find f inverse of x if it exists. Remember that the inverse of a function is defined as follows. Y is equal to f inverse of x if and only if f of y is equal to x. And remember here, be very careful with this notation. This does not mean 1 divided by f. It's just the notation for the inverse function. So notice what we're doing here is we are switching the roles of x and y, and then solving for y. And that will give us f inverse of x. That is, let's let y equal f of x, or 1 minus 4x. And now we'll interchange the roles of x and y. So wherever we see a y, we'll put an x, and wherever we see an x, we'll put a y. And then we'll solve for y. So we have 4y is equal to 1 minus x. And then dividing both sides by 4 gives us that y is equal to 1 minus x divided by 4. Or dividing both terms in the numerator by 4, we get y is equal to 1/4 minus x over 4. And we were uniquely able to solve for y, so this is f inverse. So f inverse of x is equal to 1/4 minus x divided by 4. All right, let's look at another example. Let f of x equal x squared plus 1. Let's find f inverse of x if it exists. Again, we'll let y equal f of x, or y is equal to x squared plus 1. And then we'll interchange the roles of x and y, which gives us x is equal to y squared plus 1. And then we'll solve for y. We have y squared is equal to x minus 1, or y is equal to plus or minus the square root of x minus 1, which means we weren't uniquely able to solve for y, because for any input x, we'd get two possible y values, the positive and the negative square root, which means that f inverse of x does not exist. Which shouldn't surprise you if you think of the graph of this function. It's a parabola with vertex at 0, 1, opening upward, which isn't a one-to-one function, is it? Because by the horizontal line test, if we pass a horizontal line through this graph, it's going to intersect it in more than one spot. And if the original function f is not one-to-one, then f inverse of x will not exist as a function. However, if we restrict the domain of f of x to x greater than 0, then we're only looking at this part of the parabola. Therefore, on that restricted domain, f is one-to-one. So f on the restricted domain will have an inverse. That is, if we restrict the domain of f to the interval 0 to infinity, for example. We could have also restricted it from negative infinity to 0, but let's just restrict it from 0 to infinity. Then f will be one-to-one. And therefore, f inverse will exist. So if we look at the graph of this, here is f of x on the restricted domain. And its inverse will exist. But what are we going to choose over here for f inverse of x, the positive or the negative? We're going to choose the positive because remember that the range of the inverse is equal to the domain of the original function. And if we're restricting that domain to 0 to infinity, this has to be the range of the inverse. And so the output, namely y, has to be positive. That is, f inverse of x on this restricted domain is equal to the square root of x minus 1. And let's plot this on the graph above. This is 1. Then our inverse looks like this, doesn't it? This is f inverse, which is square root of x minus 1. Now look at these graphs. Aren't they symmetric about the line y equal x? And that will always be true of a function and its inverse. Their graphs will always be symmetric about the line y equal x. And you should graph the two lines from example number 1. You'll see that their graphs are symmetric about the line y equal x. And this is how we find inverse functions. Thank you, and we'll see you next time.